Hello, everyone. My name is Rosemary Savino. I lead operations at Vanadium, a data management platform that's using innovative technology to give people and companies control and security over their own data. And I'm joined today by Dr. Catherine Ordun, who's a VP at Booz Allen. Welcome, Catherine.
Thank you so much for having me. Excited to be here today.
Tell us a little bit about your role at Booz Allen and get us started, and then we're going to talk about some really fun stuff. So
I can't wait. So I am a vice president in our AI rapid prototyping team. That gives me the opportunity to lead a lot of very innovative R&D projects, really for accelerated deployment. So this is across multiple domains for defense, intelligence, healthcare, and a variety of different, what I like to describe as multitask systems, stitching together Gen AI, computer vision, reinforcement learning, and even traditional non-AI methods to really support accelerated delivery for many of our clients.
So a small remit. You're not working on very many things.
No, I'm always bored.
Today I want to talk to you a little bit about deepfakes. Can you tell me, well, first of all, just give us a really quick refresher on what deepfakes are and then why they're so dangerous?
Definitely. So the word deepfake is a portmanteau or a mashup of the words deep learning, which is a particular type of framework that we use for all types of AI model training, and obviously the word fake. Now, this is not only videos that we might see on X, or we might see as the dashing Tom Cruise deepfake video, but this is actually across multiple types of media. In some focuses, it's a multimodal problem. Audio, text, a combination of audio and video, and sometimes just text or sometimes just audio alone. But I think it's important to say, Rosemary, that deepfakes are actually not new at all. The provenance of being able to manipulate media to incite a particular type of response has always been there. And we were talking earlier about how even using the word Photoshop as a verb really makes it kind of an underline that the notion of deepfakes have been around. And I wanted to cite a quick statistic that I read about earlier. So McAfee, a cybersecurity company, took a recent survey. They found that 63% of their respondents had seen a deepfake very, very recently, and 15% had actually seen 10 or more during the week. And that 91% of respondents are very concerned that deepfakes will interfere with the election. So it's really kind of a matter of distrust in our digital media, and I'm sure that as we see this more and more, we often can't trust with our human eyes and senses what is real versus what is fake.
Those are just amazing statistics. So really, how do you identify a deep fake then?
So this is a very interesting, timely question that I'm going to answer with both a human perspective as well as a technology perspective. So anyone who's seen all the cool AI art out there, anything from, StyleGAN, which used to be, does this person exist or not, kind of famous website, you can see things with your eyes. Right? You can see the earrings are misplaced, blur, a little bit of artifacts around the head, things that are uneven, and gives us kind of the notion of that uncanny valley that as humans we're very good at kind of sniffing out.
Six fingers,
Six
five
fingers,
legs, that kind of stuff.
Yeah, 3 arms, excellent AI art. When it comes to audio, you can also tell there's a disturbance or kind of an atrophy in the voice that is not very well syncopated. So even with our ears, we're able to tell as well. Now, those are kind of obvious things. I think at this point, many of us are trained to see. The kind of key issue here is that there's probably 80% of deepfake content. Again, this is multimodal. Can be audio, video alone, audio only, text alone, that I think would kind of fall into the rubric of a cheap fake, meaning that sometimes this is content that's not even AI manipulated. We could get a video from YouTube, we could splice little sections that are preferential for what we would like to express, and that's it, and put it out on the internet, see how viral it will go. And so those are cheap. I would think 80% of our current technology and our filters can kind of see that. It is the last 20%, these edge cases, which make it particularly hard for just with our human eye, and a fire alarm. That means I'm on the right track, so I'll just keep going. That was like a boxing bell. So the other 20%, it's very hard for the human senses to discern that. And I'm happy to go into detail about what kind of technology we can use to kind of shore up that last 20%.
I would love to hear about that technology, because I think the statistic of 20% of that is really quite high when you think about it. So tell us a little bit about those technologies.
Yeah, absolutely. So my PhD was focused in multimodal generative imagery, where I focused a lot on the mathematics of generative adversarial networks, or GANs, as well as diffusion models on multispectra imagery. So learning from that experience, there are certain tricks that these generative, especially in the imagery side, algorithms use. When we take, for example, the notion of a GAN, the GAN works in two different types of models that are all pulled into one. And I'll kind of break this down to make it easy to my point. In a GAN, which is used a lot for generating deepfake content, you've got one model that is making counterfeit stuff, making all the fake images, the fake videos. And you've got another model that is the police. They're kind of looking at this counterfeit model thinking, oh, is this real or is it fake? The goal of this game between two models is the counterfeiter wants to really trick this police model. Now, the reason I'm telling you this is because during this process, there are a lot of signals. And yes, this kind of boils down to good old-fashioned signal processing from the 90s and the 80s, the 2000s. That in this kind of modeling of fake content, there comes a point at which this counterfeit model will cheat. And there are certain signals that it can get away with much better than other signals. And then there are some signals that it doesn't really pay for this model to make. It doesn't really give the model an advantage. One of those signals I like to call as human watermarks. So when I was talking earlier, when you look at a picture, you'll see something called corneal speculation, which is the light of the eyes, right? And you can see if something is fake because maybe these two light points on the pupils will not be even. They'll be a little teeter-tottered. Well, those are a very superficial idea of a human watermark. Some are breathing fluctuations from frame to frame of video. Honed in on a specific frequency, you can kind of amplify an infant's breathing or your heart rate pegged at a specific frequency. These human signals are not what we call well preserved during this generative process. It doesn't pay for these generative models to actually make these human watermarks. So as a result, some of these 20% edge cases, we not only look at how fake the audio is, how fake the video is, but we also look at whether these human signals are being preserved, because more than likely, if it's artificially generated, it won't be. And I think this also is an interesting kind of cat and mouse game, because at the end of the day, although we're talking a lot about AI and non-AI, just regular traditional signal processing, this is intrinsically a human cognitive problem where AI is one tool. It is not a fire beats fire. You can't use AI to beat AI. You have to use a comprehensive, multifaceted, almost cybersecurity approach. But for that last 20%, there are some tools that we're investigating.
And how do you see those tools evolving in the short term and maybe in the medium term?
Yeah. So I think a lot of cybersecurity companies, they have started building these browser extensions. And that's handling some, onesie, twosie, some of these kind of cheap fakes. I think there's a couple of things that we're going to see evolving over time. Many of you have already seen when you use Instagram, there's an AI-generated content tag. That's going to become a lot more predominant. I could even see a future when you're doing Google Images, you see true ground truth image versus fake generated. But I think we're really also talking about a matter of scale and virality. So some things that we're investigating are, it's fine to be able to upload one suspicious content, 2, 10, 12, 24, but much like the McAfee statistic, this is a whole onslaught. It is a waterfall of content that is multimedia and is happening multiple times at a high frequency. How can we make a sieve that is able to detect at such a high scale? The second part is also about accuracy. How performant are some of these deepfake detection tools? And that's why I was saying that this is not purely an AI beats AI kind of notion. However, it is pretty important to say there is no universal deepfake detection algorithm. There is no one model that you can pull down from GitHub that will tell you everything is deepfake or not. This is a gallery, almost an ensemble of multiple types of approaches, many of which are not AI based.
And you know, earlier we were talking about having people with diverse backgrounds on your team to help you actually work through the diversity of tool sets that are required. Can you talk a little bit more about how that helps with not just the current state of detection, but also the evolution of that detection capability?
Yes, absolutely. So a lot of the teams I'm on are filled with brilliant computer science majors, brilliant data scientists. But as I was mentioning earlier, deepfake is not only a computer science problem, it's a human cognitive problem. So one good example is I recently met a very brilliant individual who has been developing large data sets, multi-million data point data sets for deepfake detection. This person is not a data scientist or an AI researcher. They actually have a background in TV, broadcasting, and marketing. Why? Because when they are developing kind of a testing and evaluation data set, they know the right words to elicit, the right types of media to manipulate and how. Because again, this is about a matter of eliciting human reaction and content and being able to have these diverse data sets from diverse different viewpoints is also really important. And by the way, it's not only an English language problem as well, this is also very international too.
Fascinating statistics, amazing field of study. Thank you so much, Catherine, for sharing that with us. And before I let you go, I'd like to ask you if you can give us one big takeaway from this year's conference.
Definitely, this is an easy one. So I was walking around a little bit earlier looking at these incredible different companies that are showing what they've built in terms of AI. And one thing really, really struck me, which is actually the technicality of many of these offerings. It used to be many years ago, we would have like CRM tools or something that were kind of enterprise SaaS solutions that were, pretty much generic kind of product or productivity tools. There is so much interesting. For example, there was GitLab, which our developers use quite a bit. I see a lot of voice and a lot of Gen AI kind of fusion products. And what that demonstrates to me is that there is a lot of integration of existing open source tools for industry use for different types of government use cases. And that shows me that we may be coming out of a valley of science experiments about does it work, as to opposed to more of deployment and engineering of how can it work and get integrated into different systems to truly bring value. So I thought that was really, really incredible to see among many, many incredible companies today.
Thank you so much, Catherine, for joining us today. Appreciate you, and awesome talking to you. Thank you.
Thank you.